So last time we talked about measures of dispersion, which shows us that the numbers are spread out. This time we kind of want to talk about measures of relative position. So relative position being how the values compare to each other. One of the easiest ways to compare values is by looking at percentile. Percentile is the percentage of observations or values that a particular value is larger than or equal to. A lot of times you hear about percentile when you talk about things like child weight or child height or child head circumference, things like that. When you go to the doctor's office, maybe if you're in the 75th percentile, it means that your child is larger on that measurement than 75% of all other children of that same age. Or you might hear about it when you take a test. If you're in the 98th percentile, it means that you've scored above or equal to 98% of all other test takers. So when we talk about percentile, one of the things that we want to do then is be able to find the percentile and then also find the value that corresponds to that percentile. So the first thing we want to do is, given a percentile, how do we find the value that corresponds to that percentile in a data set? So the way that we do that is we take our percentile, we divide it by 100, because it's a percent, and then we multiply by the number of observations in our data set. The only thing we want to be careful about is that the number that we end up getting is either going to be a decimal or a whole number. If it's a decimal, we take the location in the very next whole number spot in our data set when it's arranged in order. If it is a whole number, then what we're going to do is we're going to take the arithmetic mean of the value in that location and the next location. So here I've got the honeybee cinnamon measurements from previously. And so what I want to do is I want to take a chance to do an example. So for this example, what I want to do is let's talk about the 20th percentile. So for the 20th percentile, I'm going to take L is equal to N, we have 15 observations multiplied by 20 over 100. And when we do that, what we end up getting is we get 3. Now, because I got a whole number, what I need to do is I need to take the arithmetic mean of the third number and the fourth number, the one in the next spot. So here I'm going to do the third number and the fourth number and take their mean. Now, the average of 2 and 2 is 2. So 2 is in the 20th percentile. Now, because 2 is our mode, you actually see that 2 is in quite a few different percentiles, but we know that the value that's in the 20th percentile happens to be 2. If we want to figure out the percentile of a value, though, what we're going to end up doing is we're going to take that value and we're going to plug it to take its location. L is the number of values less than or equal to that given value. And then we're going to plug it into this formula. So earlier I said that 2 was actually in more than one percentile. That's because, truthfully, if we wanted to use 2 as a percentage, like to figure out the actual percentile of 2, then we would actually see that there are 5 observations that are equal to or less than or equal to 2. And so if we wanted to find the percentile for 2, we would take 5 over 15 and then multiply it by 100. And we get 33.3. So 2 is actually the value whose percentile is 33.3. So the formula is not going to go back and forth necessarily to give the exact same. If you were to start out with 1 and then you hit the percentile and then you go backwards, you're not always going to get the exact same result. That's because it depends on what question you're asking. And I bring this example up in particular because it does seem a little bit confusing. The reason why it's confusing is because usually you're going to ask the question from one side. So for example, you might say, all right, I want to know what value is in the 20th percentile. In other words, I want to know what value that is larger than or equal to 20% of all other observations. 2 happens to be that value. Remember we did it's in the third and the fourth spot, we take the arithmetic mean. So that's when you know what percentile you're looking for and you know what value you have to hit. you can almost think about that as like a test thing. I want to know how I can score better than or equal to 20% of applicants because that's the cutoff point for this scholarship or something like that. Well, then you're looking for the 20th percentile. In this case, you need to score above or equal to a 2. On the other hand, sometimes you are given the value and you want to know what percentage of observations it's actually larger than. So if I say, hey, what percentile is 6 in? So now you look at the 6, and then you take the 6 and you count how many values are smaller than or equal to it. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so you're going to take 9 divided by 15, multiply it by 100, and you get 60. So 6 is in the 60th percentile. So it really depends on which way you're looking at the particular question. Other measures of relative position include the 5-number summary measures. So there are 5 numbers that really summarize our data. The minimum is the smallest value. In our case, the minimum is 2. The maximum is the largest value. In our case, the maximum is 11. The first quartile is the value in the 25th percentile. The second quartile is the value in the 50th percentile. And the third quartile is the value in the 75th percentile. Now, you could use the formula to try to find those from previously, but the easiest way to find them is to recognize, first of all, Q2 is the median, and we know how to find that. In our case, the median is the very center number, and that was 4. Q1 and Q3 are in the 25th and the 75th percentile. The easiest way to find those numbers is to actually, once you've found the median, is to take the numbers below the median and to take the numbers above the median and find their respective medians. So the number that's in the middle of the first half is a 2, and so that is our first quartile. The number that's in the middle of the second half is a 9, and that's our third quartile. Now, there are some issues with this. One issue is that the first quartile is the median of the first half of the set of data. What do you do if you have an even number of numbers? Well, remember, it's the median. So you take the 2 middle numbers and you add them up and divide by 2. Another question that often comes up is, what do you do with the median? If the median is in the data set as, if you have an odd number of pieces of data, in this case, that means that the median is actually a value that you know, in other words, I circled. So if you have an odd number of pieces of data, you're going to take out the median. You only take out the actual middle number. If the median occurs more than once in your data set, you're only taking out the actual middle number. The way I like to think about it is, imagine that you have 15 cookies and you have to split it between 2 people. How many cookies does each person get? Well, you have an odd number of cookies. So you give 7 cookies to the first person, 7 cookies to the other person, but then you have this leftover cookie. Do you give it to the first person? Do you give it to the second person? What do? You eat it. You don't give it to either one of them. So when you take out the median, it's like that. You're not giving it to the first half or the second half. If you have an even number of numbers, the median is technically between the 2 middle numbers. So you leave everything in. And with the cookie example, you just split up the cookies half and half. I'll do a quick example of that. So if my numbers are 1, 3, 5, 5, 7, 9 in order, my minimum number is 1, my maximum number is 9. My median is in between the 5s and the 5. The arithmetic mean of that is 5, so my median is 5. And then my quartiles, because there was no median in there, that I wasn't actually taking. Now the median is 5, so you might say, do I take out the 5s? No, you don't. You leave them in because you can break up the data into 2 sets that are equal size. So the first quartile is 3, and the third quartile is 7. And so that's how you deal with the quartiles. That 5-number summary is really beneficial. It describes what's going on. So we have a graph for a 5-number summary. The graph is called a box and whisker plot. And what you do is you make a vertical bar, or if your graph is actually running up the y-axis, you make a horizontal bar. And what you do then is you make a bar for each of the 5-number summary pieces. For the first quartile, the median, and the third quartile, you make your bars longer. So you can see that these bars are longer right here. And for the maximum and the minimum, you make your bars smaller. With the first, second, and third quartiles, you're going to construct a box using them. And then with the minimum and the maximum, you construct whiskers off the box. You will notice that you don't see a whisker on the left-hand side. Now that's because my minimum is 2. So if I make that whisker right there, it was made in black, and then I draw the whisker to it, it's all sitting on that same bar. So typically you do see 2 whiskers coming off from it, and there is a whisker, it's just length 0.